Start spreading the news. Do, 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 do. It's pre-calculus time. Do, 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 do. I want to be a part of it. AP calculus. But that means I gotta do my work for my pre-AP class. Ba-da-da-da. Make sure I watch videos and bust my... Okay, here we go. Another nice little pre-calculus honors lesson. I hope you like my singing. Let's start things off with a couple do problems. Okay, 2 definite integrals without a calculator. I want you to copy them down after you pause the video. I want you to try them. Okay, we're back. All right, let's take a look. You'll have an assignment coming up assigned, it's Thursday for homework. You'll have Friday to work on it. Today's Monday, I believe. So an assignment coming up there. You're going to have some problems where the calculator is required and some problems where I want to see work. Like these 2 problems right here, you know that to evaluate a definite integral on your calculator, you can go right to a little math 9 action, math 9, and evaluate it that way. But on the AP exam, they're not going to give you a problem like this when you have the actual graphing calculator in front of you. It's going to be on the non-calculator section. So make sure you take a look at that take-home assignment for the problems where it actually says, to show work. Okay, I want you to integrate by hand or show the, integration process, whichever way I actually write it down. Don't just go to an answer. We have to split some things up that way. Usually I give one question with a calculator, one without. Things obviously a little bit different this year. Anyway, so this problem over here, hopefully you realized it's a U-substitution situation. You got multiplication going on here. The argument of E is not one single X. Okay, so hopefully you took a look last chapter. You studied your integration. You know what's going on. I'd set U equal to 2X squared. Some people right now are like, well, I don't even know how to integrate this thing. Well, that's trouble. You should have known that last topic. Okay, get in touch with me. Send me a reminder. Send me an email if you have questions. I'm going to start doing Google Meets. I wanted to do Thursdays, but there's a schedule for it, and I have to do it earlier in the morning because of my craziness of a daycare at home. So I'm looking at Mondays, probably either 8:30 or 9 a.m., which means that this is a video on a Monday. There could have been a Google Meet this morning, or maybe you're watching this like the night before or something, because I usually post it early. Anyway, so over here, if you have any questions, let me know, obviously. Over here, it's funny because they call it U-Substitution. But usually we say they should really call it U-Substitution, because not only do we sub in for the U, we got to sub in for the dx. And we know it's going to be du over the derivative of u is equal to dx. But remember, with the definite integral, it's not even 2 substitution, it's 3 substituciones, okay? Because we have to sub in for the bounds as well. And what I mean is this: if you leave this x here, obviously he's still there, right? But not for long. He's going to get canceled out. This becomes e to the u. Take out the dx, put in a du over 4x. I'm telling you right now, on my test, this is going to be partial credit. It's going to be, like free response types of situations. If you put a 1 here and a 2 here, you were wrong, okay? These bounds represent x bounds because of the dx. The second you take out the dx, you put in a du. You need bounds that represent u bounds. How do you transition from x to u? Yoo-hoo! This guy right here, okay? We know that when x is equal to 1, u is equal to 2 times 1 squared, which is 2. And we know that when x is equal to 2, u is equal to 2 times 2 squared, which is going to be 8. I'm not hungry because I just ate. Okay, so that's actually the bound set up the appropriate way. This is an equivalent integral. If I were you, I'd cancel out the x's. How quickly can we move here? I mean, this 4 right here, he's a constant connected by multiplication. It's not even a 4, right? He's a 1/4. Bring him out. So you can pull him to the side. If you want, you could rewrite the integral from 2 to 8 of e to the u with respect to u. I'm not going to do that, okay? I'm just going to cover up the 4 because we took him out, the 1/4. The x's are gone. And then I realized I'm just going to integrate e to the u with respect to u. I know that integral is e to the u. We don't put the plus c because we're evaluating from u equals 2 to u equals 8. Right now, if you want to take out that u and put the 2x squared back in there, you need to change back to the bounds of 1 and 2. It's extra work, okay? And there are problems, you'll see, where they specifically say, using the following substitution, which of the following is an equivalent integral to the original. So you got to be able to handle the problems this way. So how do you want to handle this here? Plug in the upper bound first, right? So 1/4 e to the 8th minus 1/4 e squared. Kind of nasty too. I mean, it's not a horrible way to leave the answer. Some people might say this is the same as e to the 8th over 4 minus e squared over 4. Which means what? E to the 8th minus e squared quantity over 4. It's not the worst thing in the world, okay? They might factor an e squared out of the top. In fact, right here, you could factor out a 1/4 e squared. then things get really cool, okay? If you factor in e squared out of e to the 8th, you know, e to the 8th divided by e squared, subtract exponents, e to the 6th minus 1, and then you could actually factor this. This is a difference of two perfect squares, 1/4 e squared, and then we have a little double bubble. Square root of e to the 6 is e cubed. Square root of 1 is 1. With the difference of two perfect squares, we know the signs are always different. So that's probably what they're looking for. You know, if it's actually, you know, your test, you don't have to show the simplifying, okay? So really, once you get here, this is an appropriate answer. This is. I'll try to set it up in a way where it's easy to check. Maybe I'll give a multiple choice, but I'll also ask you to show your work. Then you'll see, you know, whichever one is in multiple choice, that's the one you want. This one's a little filthy right here, you know, a little antiquated. You should be able to get this far easily. After that, the simplifying, it's stuff that you did previous to this course, but people do struggle with it a little bit. Make sure you work on stuff like that, okay? Especially if you want to be in BC. Algebra can't be any type of an issue. In AB, there's still people who take it who have no idea how to do algebra and somehow still end up okay, all right? But hopefully that's really because they put in the work to actually understand what's going on algebraically. This guy looks kind of harmless here, right? Okay, but it's actually not the easiest integral in the world because it's not basic integration yet, okay? You know, obviously we see division right there. It's kind of tough to talk about arguments here. I mean, this is a polynomial function. His argument is going to be his base, but he's only one single x. The problem is the division. Can you get rid of the division somehow? Think about it, okay? We've done stuff like this before. You can't factor something out of the top and cancel with the x squared downstairs, but you can get a little many over 1 going. Split the divisions, nice little heart, okay? And then it actually becomes basic integration. The integral from 1 to 2 of we have x over x squared minus 4 over x squared with respect to x. Technically, right now, you turned a quotient into a quantity, so you want those parentheses, and you probably want to simplify it just a little bit more. Okay, over here, x over x squared is really 1 over x, right? Minus, I'll write 4 over x squared is 4 times x to the negative 2. And you should know why I'm doing that, okay? Just to prepare for the integration that's about to happen, okay? You usually want to get the x up on the same level. Here we don't, because if you try to integrate x to the negative 1, add 1 to the exponent, divide by that number, you'll end up dividing by 0. This is an ln type of situation. The integral of 1 over x, that's somebody's derivative in there. Whose derivative? ln x's derivative. But we say ln absolute value x to ensure that we have a positive number inside the argument of ln, which is the way it needs to work as far as domain is concerned. Pull the 4 to the side, constant connected by multiplication, integrate x to the negative 2, so add 1 to the exponent, divide by that number. Then evaluate the entire thing from 1 to 2. Maybe clean it up slightly, right? ln absolute value x. Bring this negative 1 upstairs. Negative 4 times negative 1 is really positive 4. Bring the x downstairs. You know, stuff like this, okay? This is stuff you should have known how to do before you got to this course, okay? So make sure you take a look. You practice stuff like that. You never want to get a calculus problem wrong just because you're doing something silly with this stuff over here. So anyway, let's plug in the upper bound. ln absolute value 2 is really just ln 2, right? Plus 4 divided by 2, which is 2. Minus the plugging in the lower bound. ln absolute value 1 is just ln 1. Okay, kind of looks like absolute value n. Sometimes I make the 1 look like that, just when there's an ln. Plus 4 over 1, which is just 4. So this gives us what? ln 2. Listen to that. Laundry's done. Plus 2. Okay, here we have minus the ln of 1 is 0, so minus 0. I'm not going to write it. Minus 4. I'm losing my mind. Here we have ln 2 minus 2, and that's probably as nice as it's going to look. Okay, so, you know, practice these, okay? Integration, always going to give people problems, okay? I don't know if I circled this with the many over 1, if the paper was even, you know, in view of the camera. Hopefully it was, okay? But integration is not like differentiation. It takes a lot more practice. And we've been focusing on the definite integral mechanics this chapter. That's just mechanics right there. We've also talked about how the definite integral can give you the area between a function and the x-axis as long as the region lies above the x-axis. Or if you want to ensure that you have a nice little formula for area between two curves, even if you use the x-axis as a curve, that's something else we've been talking about that's very important. Recall, who knows how to spell? Not me. All right, we got a little star action going. Let's get our best star out there. So maybe Emily Ferguson. What do you think, Fergie? Little star out there? Star! You better be watching this video, okay? If you're not watching these videos and I'm giving you shout outs and stuff, just rude. If you want the area between two curves, area between two curves, and we'll talk a little bit more about this today. That's going to be area equal to integral. There's two formulas. We only worry about one this year. x sub 1 to x sub 2. It's leftmost x value of the region up to the rightmost x value of the region. When you set up your integrals on your own, you're probably going to have a lower bound that's lesser in value than the upper bound, but it doesn't need to be that way. You know, this could be a 15 down here, just so you know, even with an upper bound of 2. Usually you don't create those integrals. Sometimes they just end up getting created by changing bounds, or they'll actually, you know, just be created by what the nature of the problem is. Stuff we'll talk more about next year. Make sure you draw a sample rectangle, okay, in your region. And if you see throughout the entire region, the upper function's consistent, the lower function's consistent, we could do upper minus lower. And we're going to integrate with respect to x, which means we want whatever y is equal to, okay, for upper and for lower. So this is whatever y equals, you know, so if y equals x squared and y equals x, you'd have x squared minus x, or actually x minus x squared, because usually you'd have the x being more upper than the x squared. Really depends on the situation. You know, as far as the homework was concerned, number 11 wasn't really an upper minus lower situation. You could have used it if you want. My graph looks horrible, okay? But if they just want the area between this graph and the x-axis from x equals 1 to x equals 3, as long as you could plot a couple points and realize the region's above, then you can go right ahead and just integrate. You know, technically, if you draw a rectangle, you'll see that the upper function is always going to be y equals 3x squared plus 2x. The lower function is actually always going to be y equals 0. So you could have said area is equal to the integral from 1 to 3 of the upper function, which is 3x squared plus 2x. Whatever y equals, right? Minus the lower function, which is just 0. And then with respect to x, you'll see it's the same thing as what we have here. And it seems stupid, right? People are like, why do we put a minus 0? I'm a math mastermind. I'm in pre-calculus honors. Trust me, stuff like this is actually going to be a lot easier next year. It's going to make problems easier to do. Make sure you practice integrating by hand. I know you have the calculator. Look, you're not allowed to use the calculator for any piece of it, okay? And I know you could just easily dupe me on assignments. And they're all take-home assignments anyway. Trying to trust you guys, okay? If you want to succeed next year, you better be doing this work. If not, so long, Polly. Number 22. This is a cool little AP problem right here. 2007 AP, I think. Wow, 13 years ago. So if you graph this guy right here, you're allowed to use the calc, so it shouldn't be an issue. Hopefully you opened up the window. This year, 2007 on the AP, a lot of students actually got this problem wrong, because when they tried to graph this function, 20 over 1 plus x squared. I don't know, let's see what the new calculator is, what it looks like. If you zoom 4, yeah, pretty much the problem they were having. They thought that there was a vertical asymptote right here at x equals 0. They thought this stuff just, you know, ended up shooting upward infinitely. You can't use any of these definite integrals unless a function is actually continuous. Otherwise, you need to split integrals up. More on that when we get there. But there are actually kids taking the AP who thought that there was a vertical asymptote here. Well, vertical asymptotes only occur at x values that make a denominator equal to 0. 1 plus x squared, it's impossible for it to actually be equal to 0. If you set equal to 0, you get x squared equals -1, and that means x would actually have to be equal to I, right? Okay, but that's a reject. That's an imaginary solution. We only talk about real numbers in this calculus class, and next year as well. When it starts getting to imaginary numbers in calculus, that's when stuff really starts taking off. Engineering math, you got your heat equation, you know, the equation that distributes sound across a drum. Really cool stuff, but you won't be there for years. Anyway, people actually couldn't even graph this, okay? Not realizing that if you just set x equal to 0, you get back 20, then the y-intercept is 20, okay? So if you she came in through the bathroom window, and you actually take that y max, which is only 4 here, and make it like 21 or something like that and graph it, then you could actually see the picture, okay? So you got to know how to play around, and we talked about stuff like that with the graphing calculator. Hopefully after that, not too much of an issue, okay? It should be easy to see it's upper minus lower. Draw that sample rectangle, as terrible as it might seem. The bounds we know from -3 to 3. You could actually go from 0 to 3 and then put a 2 in front. Not really necessary here though, because you're using the calculator, okay? You can just put the integral right in. Math 9, get your answer. Okay, so different ways to do problems, you know, talking about how to just, we're going to do number 16 on the packet yet, you know, talking about this topic, how to do definite integrals mechanically, you know, whether it's a basic integration or U-Substitution, talking about it represents the area between a function and the x-axis, as long as the region lies above. Then we talked about the area between two curves formulas. We're doing these problems with calculator, without the calculator, a lot of stuff going on. Number 16 here, we're going to use the calculator. This is a cool situation here. Find the area bounded by y equals Twix, the only candy bar with the Cookie Crunch, you said it, and y equals this cubic right here. And you might notice that there are two regions, okay? And the first time that's happened, this is where drawing the rectangle becomes a bit more important. It's a bit more important. If you draw a rectangle anywhere from, this x value to this x value right here, so we're talking about this x value up to this x value, you'll see that the upper function is always going to be the cubic and the lower function is always going to be the linear until you cross over this x value, and then suddenly for the second region, they swap, right? Now the upper function is the linear and the lower function is the cubic, and that actually happens from this x value up to this x value. So when you want to talk about what area is equal to, okay, actually, I want to put a equals down here. You'll see why in a minute because I want to write some other stuff up here. So area is equal to, we got the integral, two integrals here, okay? First, we actually have to worry about getting the area of this region. It's just the area between two curves. It's upper minus lower from this x value up to this x value, right? Here's the leftmost x value of the region. It's actually the x value of that intersection point. Here's the rightmost x value of the region, and it's the x value of that intersection point. You could set these equal to get those intersection points. It becomes disgusting. You have the calculator to do that, okay? But check this out. I'm actually going to say this. I'm just going to call this b right here because it's going to be some disgusting irrational number, okay? And I'm going to say this guy is c. Why didn't I start with A? Because I said area is equal to for big A over here. So if you're going to use the big A, you should start with big B. If you don't want to use the big A, you don't need to. You just write up the integrals. Then you can put an A right here. But you can see that first integral is going to go from B to C. Make sure you go from, left to right. Usually when we set up the integrals on our own, that's what we do. Upper function is going to be the entire x cubed plus 2x squared minus 3x plus 1, all with respect to x. Oops. So I left something out right there. It should be upper minus lower. Okay, so here's my upper function right here. Sorry about that. And then I want to subtract the lower function. We know the lower function is just a monomial. Okay, so we don't have to actually put parentheses around it, but we do need parentheses around that whole thing with respect to x. And then a plus sign, okay, because that's not all the area. That's only the area of this region right here. Now I want the area of this region right here, which you can see goes from x equals c to x equals d, we'll say. And that's going to be the integral from now c to d, upper minus lower, whatever y equals. Did you notice the upper this time is 2x minus the lower, which is the entire quantity, okay, x cubed plus 2x squared minus 3x plus 1. And all of this needs to be integrated with respect to x. So technically the way it's set up right now is incorrect. I need another set of parentheses or a set of brackets right there. That's your setup, okay? And some people are like, well, that setup's great, Berto, but what the heck is B, C, and D? Good question, okay? If you're going to write stuff like this out, and you're allowed to write it out this way, you got to tell them what B is equal to, what C is equal to, and what D is equal to, okay? And that means we're going to go to our trusty, hopefully not too dusty, graphing calculator. Some people have been getting in touch with me. I'll start with the 2x, then I'll put the cubic, and telling me that their calculator's running low on charge. If you got a USB to a micro USB cable, I believe that's what you need to charge this thing in the computer. If you don't have something like that, you might have the yellow calculator I handed out to most people. You could just replace the batteries. Haha, take that. But if you don't have, a means to charge it, if you go to my website at the top, I believe there's a link to a 90-day trial for an emulator to use a TI on your computer. So you could try that. I'm going to zoom 6 here. Look, I'll zoom 4 first, but I don't think you see the full picture when you zoom 4 here. It's not really the greatest thing. It's not the worst thing in the world. I'll zoom 6. Zoom 6 is not so horrible. I mean, we could use it when it serves our purpose here. And pretty good picture. Okay, with zoom 6 on this calculator, I got to calculate this x value, which means I need to calculate this intersection point. Should be easy to do. Calculate that intersect. We know how to do it. Let's go, bug. And you'll see how nasty it is. See how it says x equals? If you go to the quit screen, hit X, hit enter, you'll see it's right there. So there's my B. I'm gonna store it right here on my paper, negative 3.507018644. And I'm also going to do this because in my calculator, when I put in this big integral, you could write out that whole number. It's going to be extremely annoying. Or you could just do this. Hit store. The store button, okay, right below LN. And let's store this in for a letter. Why not B? Because that's how we have it set up. Just make sure if you're doing this stuff, which is kind of silly for this problem, what you could do is you could just put the truncated version if you want, negative 3.507 right here. But when you evaluate the integral, you actually need to use the entire value. So that's why it's a little bit safer to do this. And then some problems, there's like A, B, C, D, and E, on the AP exam, use the same bounds for each problem. So it's lucrative to store them in. Let's calculate intersect to get what C is equal to. right around there. And you can see that C is approximately 0.221876 1623. That'd be the year Mr. Harrington was born right there. Let's store that in for C. So make sure you store it on your paper and you store it on your calculator. I know it's a little time consuming, okay, but if you practice, you get better at it, okay? And I'm also teaching it here, so I'm kind of slowing it down. Some people probably think I'm moving too slow. Sometimes whenever I teach, people think I'm moving too slow. Some people think I'm moving way too fast. Pacing, big part of the curriculum. What does this end? 2,482, 2482, the year I plan to live to. Okay, let's store that in for alpha D right there. And now you could actually put this entire thing in your calculator, okay? You have the integral set up, and you have what B, C, and D are equal to. So let's have some fun right here. And let's be smart about it, okay? Remember, I got the linear in Y1 and the cubic in Y2. So let's get a little math niner going on. Math niner, nothing could be finer. And this integral goes from what? B to C, so alpha B up to alpha C. How cool is that? Not having to write out the entire thing. And here it's the cubic minus the linear. That's Y2 minus Y1. Little alpha twaithy, Y2 minus little alpha twaithy, Y1 with respect to X. And then you can just put the plus sign. Why don't you actually hit the plus sign, Berto? Okay, little math niner. Now from C to D, where the last one left off at C, we're going to pick up right here. So little alpha C up to alpha D. And then you can see inside here, we now have Y1 minus Y2. Y1 minus little alpha twaithy, Y2 with respect to X. And look at that. Now just hit enter. And I get 26.153 approximately. Okay, so a lot of stuff going on. It's time consuming. You want to practice stuff like this with the calculator. Remember, the calculator is a tool to help you be able to do things that you normally wouldn't be able to do by hand. You could actually do this problem by hand. You could do the integration by hand. It's extremely annoying, but you could do it. The problem is the irrational bounds plugging them in. Can get really filthy, and getting the bounds by setting these equal, really deals with stuff algebraically that you guys don't talk about anymore. It's just out of vogue. They don't ask about it in the AP exam. We do it in the regular Math 12 class, but not this class. Something known as Descartes' law of signs, rational root theorem, synthetic division. Okay, it's antiquated topics. So that's how you do something like this without a calculator. You won't have to worry about that these days. One more, and then we'll be done. Let's go into 18. It's a problem from an advanced placement exam. I think it's a 2005 exam, but I'm not sure. But it does look quite familiar, strikingly familiar. Calculated situation. They give us a nice little graph. Let f and g be the functions given by f of x is equal to 1 plus sine Twix. G of x is e to the x over 2 power. Let r be the shaded region in the first quadrant. Sometimes that's important, right? Because if there's a version of it outside the quadrant, you don't care about that. Enclosed by the graphs of f and g is shown in the figure above. Even though it's pretty easy to see the region R right here, sometimes it's more complicated. We want to find the area of region R, and we want to use our calculator. And you can see this is the area between two curves, okay? And what do we start by drawing? A rectangle. A rectangle. We only draw one, but we really imagine like an infinite amount, right? Or like 7, something like that. But you can see the upper function's always f of x, the lower function's always g of x. You could even write it up that way. You could actually say, hey, the integral of, upper minus lower, you could straight up say f of x minus g of x. Oh, with respect to x. You don't need to write what the actual functions are, which can be useful, right? Because sometimes if you're subtracting a quantity, you need parentheses and people mess that up. So even if they told you y equals for both of these, you could redefine one as f of x and redefine the other as g of x and still write up something like this, okay? So there are a lot of different ways to write things up on the AP exam, as long as it's easy for the people who are grading to follow your work. We need bounds here. I think without a calculator, you can tell me the lower bound is probably 0. It does say the first quadrant. The first quadrant begins at 0. Technically, since it is a calculator problem, these could intersect at like 0.001 or something like that. The moral of the story is, when you have the calculator, you shouldn't be guesstimating anything. If it's a non-calculator situation with a graph on an AP, you can actually guesstimate what a value would be. You'd be like, yeah, that looks like 0. But because if it was something extremely close to 0, that was a ridiculous number, you'd never be able to calculate that without a calculator anyway. But with the calculator, now you have the means, not the standard deviations, but the means. Statistics joke. I like to joke about things that mean nothing. I'm just kidding, okay? Statistics is actually extremely important in the world today. Extremely important for you guys to know how statistics can be, manipulated and slanted, okay? It's kind of scary, right? People all the time, they're like, well, studies say. And I'm like, well, who does these studies? Then they're like, oh, Harvard University. Oh, they're very smart, so they must be right. Yeah, smart enough to slant the data. Anyway, sorry, a little statistics rant right there. Hope that AP was okay, by the way, especially with that teacher that you have. Tough luck for you guys. So here, I don't know, maybe Zoom 4. And you actually see that I'm getting a lot more here, and you better be in radian mode, by the way, with this trig right here, never degree mode in this class. We're getting a lot more than the picture we actually have. Here's our picture. That's what we want to focus on. We actually have a truncated graph. They do that all the time on the AP exam. If we calculate some intersects here, you'll see that the lower bound is 0, so that's the hotness right there. And the upper bound is going to be pretty nasty and irrational. Oop, there it is. Okay, so I know that the upper bound, I'll even do it this, I'll call it B, and then I'll say let B equal, actually, you know what? Instead of doing that, let's do it this way. You can obviously do that. Okay, call it B and write down what B is equal to. We did that in the last problem. You could also do this. Since we're not using this bound again, we're only answering one little part here. You could put either the rounded or the truncated bound up here. There's absolutely nothing wrong with doing that, okay? You could put 1.136, that's the rounded version, or 1.135. But when you actually get your answer, you need to use the true value, okay? You could either write out the whole thing, or maybe just in your calculator, you store it in for B. Now you get your little math 9 set up, and you say the integral from 0 up to, look, either put B or write out that whole thing. Technically, B is a lot bigger than this. This goes on forever. It's an irrational number. But anyway, if you write out that many decimal places, you'll probably still get a close enough answer if it's rounded to 3 decimal places. That's the way they have it set up. Upper minus lower, f of x minus g of x. So that's what? y1 minus y2. Okay, with respect to x. And I get approximately 0.429. All right, look, really nothing wrong with actually, writing down. I'll put or here. You could say let b equal 1.135692535, and then set up the integral from 0 to b of f of x minus g of x, all with respect to x. So many different ways to do this. I mean, technically, you could just say let b equal 1.135 or 1.136 and do this. Whenever you truncate a round on the AP exam, you're still writing down a representation for the true value, okay? You just are shortening it, okay? So it's almost like you're replacing it with a variable, only the variable happens to be the truncated or the rounded decimal answer. So do the best you can with stuff like that. Don't freak out about that right now. So really today, some more definite integrals. Make sure you practice stuff like this, you know how to do it. Your area between two curves we talked about with Calc Assist today, okay? So usually not too bad for people to pick up on, but practice these types of things, okay? Tomorrow, just more combined practice, okay? And the same thing with Wednesday. Thursday, we'll do a Q type of problem as well. Really the last big topic here next week. May start a new topic that sometimes they get to. We may not. We might just go into some final review. There's no final exam, but the review is still good. I'm not sure exactly 100% what's going to happen yet, kind of playing it by ear. We'll see what happens. The important thing is that hopefully you guys are, healthy and safe out there, and I miss all of you, most of you, and hopefully we'll see you all in the beginning of the school year. And this is Berto signing out. Adios.